Today we're going to be looking at algebraic fractions. So what are algebraic fractions? We definitely know what is a fraction already. So a fraction is something that has a numerator and then a line, and then after that there's a denominator. So an algebraic fraction is simply a fraction whereby the numerator and the denominator are in algebraic terms. Okay? So having an algebraic expression itself. For example, maybe we have 2x plus 1 over 3x squared minus 7. So something like that. So this would constitute to be an algebraic fraction. Alright? For an algebraic fraction, they definitely behave the same way as a numerical fraction. Okay, so the behaviors that you have already been familiar with since primary school, it will still apply. Some important behaviors just to recap, okay, and have a better understanding that algebra will also work that way. So in numerical fractions, so for instance, we know that 2 plus 5 over 3, okay, if I break this thing up, okay, I know that 2 plus 5 is 7, so 7 over 3, okay, it can be written as 2 over 3 plus 5 over 3. Do we agree with this? This is what we have been familiar with about numbers, okay, numerical fraction. So therefore, I can say that it is 7 over 3. Okay? But what about over 2 plus 5? Okay, so instead of having the plus sign at the top, okay, I now have the plus sign at the bottom. Okay, so my question here is, right, is 3 over 2 plus 5 equals, okay, to 3 over 2 plus 3 over 5? How many of you think that way? Who thinks that this thing is actually equal? Anybody? Who thinks that it's not equal? Right? Who is not sure? Okay? Surely this one you can be sure if you were to press calculator, right? Okay? So the answer is that it is not equal. Now, why is that so? Okay? The reason is because, and you all take out your calculator. Tell me, 3 over 2 plus 5. Actually, don't really need calculator. You can tell me what's the fraction, right? The answer is 3 over 7. Okay? Then what about the right side? If I were to think about 3 over 2 plus 3 over 5. Press your calculator and tell me. What would it be? Victor, what do you think? 6 over 7. I tell you it's not equal already, right? You sure or not? 6 over 7. Press up. Your calculator, right? Or fingers, right? Who says 6 over 7? 21 over 10. Yes, what is it? Error? How can it be numbers? How can you get maths error? 21 over 10. 21 over 10, yes. Okay. Now, firstly, I want to clarify Minzer's mistake. Okay, maybe some of you also think that way. When it comes to fraction, alright, 3 over 2 plus 3 over 5 is definitely not taking the top end together and bottom end together. We never do such thing, right? We always need to change into same denominator first, then we can add fractions together or subtract fractions together. So this is definitely not true. Alright? So, but in a calculator, we can simply see that 3 over 2 plus 3 over 5 equals to 21 over 10. So we skip through those difficult working. Because I just want to show you that, okay, if the left side of the equal sign is 3 over 7, right side of the equal sign is 21 over 10, surely they cannot be equal, right? Okay, we know definitely that these two numbers are not equal. Alright, so therefore, what we can see over here is, if the plus sign is at the bottom, you cannot split the fraction out. Okay, so if plus is at bottom, cannot so-called split the fraction. Alright, whereas if the plus sign is at the top, then you can do it. Okay, so when it comes to algebraic fraction, we can conclude that in a generic way, if the plus sign is on top, I can write it in this manner, and if the plus sign is at the bottom, it is definitely not equals to, so this is the sign for not equals to. Right? So we need to actually be clear about this. Okay? So there's no way for us to break up this kind of fraction. There's no way. Okay? It will just remain in that manner. Alright? Are there any questions? Am I going too fast? Yes? Okay. Fast because you cannot write in time. Okay, I'll try to slow down a bit. Okay, so by the way, right, other than just plus, okay, the same will apply also if it's a minus. Okay, so plus and minus are rather interchangeable. They have the same similar properties. Okay, so also the same if it's minus. Alright? Okay, I want us to ask ourselves now, okay, this question. What about 2 over 3 times 5? Okay, without using a calculator, can you tell me A, B or C, okay, is actually equal to 2 over 3 times 5? How many of you think that 2 over 3 times 5 is actually equals to 2 times 5 over 3? Who thinks that they are going to be the same meaning? They mean the same thing. Do you understand my question? Huh? Your answer is none of them, huh? Oh, okay, maybe I put another option. None of the above. Okay, and then maybe a E. I don't know. Everything you also say, I don't know, then this part will just explain everything for you all, right? Okay, so try to think. 2 over 3 times 5. Okay, do I just bring it up to the numerator and multiply? Or must I put both top and bottom when I write this? Okay, or actually both of these are the same meaning. Alright, or none of the above, you're thinking of something else. Okay, or I don't know. Alright, so how many of you think that this is equal to 2 over 3 times 5? Alright, got a few. Okay, about 3 people. Maybe just let me write it down. Then who thinks that it's option B? That when I write this, it actually means this way. That I multiply on top and multiply at the bottom. Okay, so about 3 people. Who says that it's C? That both A and B, everything here means the same thing. It's all the same number that will come out. Alright, so nobody. Who says none of the above? Okay, none of the above. Right, so maybe about 4 people, I think. Who says I don't know? Come on, surely you know why. You pass primary school PSLE. Okay? So, okay, none of the above. Maybe Ryan, do you want to tell me what do you think actually? Why do you say none of the above?
Because 5 is 5 times 5 over 1.
Yeah, okay, so 2 over 3 times 5, 5 is 5 over 1.
So it changed the denominator to 3, then up, then the 5 will change to 15.
Oh, okay. So he thinks that 5 over 1 need to change into 15 over 3.
Actually you can cross multiply.
And cross multiply some more.
Okay, I don't know after that.
Okay, when it comes to multiplication or division, must we make it the same denominator? No need, right? Okay, actually even if we make it into same denominator, the answer will simplify to be the same because this will give me 30 over 9. Okay, 30 over 9 simplify, divide by 3, 10 over 3. 10 over 3, right? This one, 2 over 3 times 5, press calculator, what do you get? 10 over 3, right? 2 times 5 over 3 is equals to what? 10 over 3. What about 2 times 5 over 3 times 5? Press. What do you get? 10 over 15. Your calculator give you 10 over 15, man. 10 over 15 can be simplified. I know that 10 over 15 we do mental calculation. It gives you 2 over 3. So 2 times 5 over 3 times 5, you multiply same thing on top, multiply same thing at bottom. Confirm when you simplify it's the same thing, right? Because can cancel, alright, you simplify it, right? When you do the process of simplification. Okay, so actually, why I'm trying to ask this is to make sure that we are clear in understanding what an expression like that actually means. So we see that for option B, it is actually 2 over 3, not equals to 10 over 3. So this is definitely not an answer. Since these two are actually equal, okay, A is actually equal to what the question is saying. Alright? Although, okay, what Ryan originally said, yes, you also get the same answer, but it is a redundant process to do this. Okay? This is not necessary. Alright? So what I'm trying to say over here, okay, is that I want you to make sure you understand when I have a fraction and I multiply by a number, okay, it is actually 5 over 1 that we are saying, and we only take numerator times numerator, denominator times denominator. This is the skill that we have learned since primary school. Don't tell me you all go for 2 months break, your primary school also forget already, is it? Now that you are all in class, the eyes that I see from, the gaze that I see from your eyes is very terrifying. It's like, I'm in a secondary school, teaching primary school kids, you know. You look like you don't understand me. Am I in the same classroom as you? No? So, okay, that's the answer, right? The answer is A, okay? I think I gave it to you in the worksheet, right? Yes. Okay. Whatever that I'm writing here is all inside your worksheet also. Okay, in case you forgot the routines. Yes, now. Why cross multiply? Cross multiplication only happens when there's an equal sign in between. You do not cross multiply like that. There's no such thing. Okay? Cross multiply 2 over 3 times 5 over 1. What do you mean by cross multiply? 3 times 5. I also don't understand what you're talking about. I also don't know. Okay? So 2 over 15 then? No, right? Okay? So cross multiply doesn't if I have A over B times C, C is actually C over 1. Okay, so I will have A times C, which is AC, over B times 1. Alright, so this part is very important when we actually go into the second section, right, of this chapter. Okay, so we have all the behaviors that we actually understood from the numerical fraction to be brought over to algebraic fractions already. Right? So we will now look into simplifying, okay, our algebraic fractions. We have looked at plus minus just now, then over here is a times. Okay, what about if I have divide? Okay, so looking at simplification. So if I have numerical fractions here, an algebraic fraction here. So just now I was actually mentioning about simplifying, right? If I want to simplify 4 over 14, that means I want to reduce it to the lowest terms. Okay, so 4 over 15, if I want to simplify, what actually will I get? What will I get? 4 over 14. Come on, don't need press calculator one, right? Sorry? 2 over 7. Can you tell me how do you get 2 over 7 when you use mental sound? Very good. Okay, top and bottom I divide by 2. Because both 4 and 14 there is a common factor of 2. So actually I can divide by 2. So what we usually do is that, okay, we can cancel it and then I write 2 over 7. And that is because I divide by 2, divide by 2. Alright? So this idea of cancellation, okay, is actually the same meaning as dividing by common factor. Alright? So now when it comes to algebra, then how? Okay, algebra confirm between A, B and C, how will I know whether got common factor or not? Don't tell me that common factor is whether is it a vowel or a consonant. No. Okay, it doesn't work that way. So we understand that 2 times A times B is the same meaning as 2AB. 8B is 8 times B. Alright? So we observe the numbers first. Between 2 and 8, what is the common factor? 4. 2. Okay? So we can cancel away. Divide by 2, divide by 2. So 8 divided by 2, I will be left with 4. Right? Then 2, I cancel away, nothing else already. Okay? It's actually a 1. Right? Next, between A, okay, A is at the top, but A doesn't appear at the bottom. So is there anything to cancel? No. Alright? You cannot cancel, take A and cancel B. No. Okay? Hayward is Hayward. Hayward is not same as Howard, right? Okay, or the 2 letter difference only. Okay, so A, just leave it alone. Then next we look at the B. So there's a B on top, there's a B below. So both of it has only 1B, then we can cancel only 1B. Okay? Then the B, no more of it. Alright? It's actually because it becomes a 1. Right? So when it is no more, it's because it is actually a 1. But we don't really need to write the 1s, otherwise it's very confusing. Right? I suggest that when you do cancellation, always use a pencil. Because I don't want a case whereby you go and cancel using a pen onto the question paper, the question itself that is printed in ink. Because if you want to do a double check or your ink actually has your pen has a lot of ink, okay, then end up you're going to cancel away the question the examiner may not be able to give you a new question paper, right? So try to cancel in pencil instead, right? So that you can at least erase and take a look at the question again. So therefore, when you want to simplify this, the answer is that there is only a single A left on top, and at the bottom, I will be left with 4. So simplify is A over 4. Okay? So when I taught this 4 years ago, I got one student who was very weak in maths. Maybe some of you will also be having this same idea. Okay? But it's okay, because by that student, although weak in maths in Set 2, end up Set 4 still can graduate and get at least I don't remember what's the grade, okay? But got at least a grade 3 lah, alright, remember. A plus B over AB, okay? Set 2 she tell me, cancel mah, right? A cancel lor, B cancel. So I ask her what is left. She tell me the answer, like that leh. Okay? You think make sense? Surely it doesn't make sense, right? How can it be like that? Then after that, this one was when I taught NA. Then after that, my other colleague was telling me, another student express A plus B square divided by A plus B, cancel also. The answer is square. But like that, right, it's 2 not square, okay? So it doesn't work this way, alright? So later on, I'll cover about something like that, okay? But this one, I just want to emphasize that it doesn't work because it is a plus sign over here. Okay, so the cancellation happens only when throughout the things at the top and at the bottom right is only multiplication. Okay, so cancellation cannot apply if plus or minus, okay, appears. Alright, so it is depending on how the plus and minus appear. Alright, if there are brackets, okay, then maybe it can still work, right? So this is not true, okay? This one actually answer is A plus B lah. Okay, I can cancel away one of the A plus B. So I'll talk more about it later on. Concepts, the ideas that we are trying to draw between numerical fraction and algebraic fraction. Let's do a proper example, okay, where we're going to handle algebraic fractions. So now that we have 27x squared y cubed over 12xy to the power of 4, okay, how are we supposed to go about simplifying? So we also borrow the idea of cancellation, right? In doing this simplification, first of all, okay, I want you to take note that in this xy to the power of 4, it only means how many x are there? Xy to the power of 4. There is this power of 4. Can you tell me, is there 1x that should appear or 4x that should appear? Is it x times x times x times x? And then after that, times y times y times y times y? Are they equal? Yes? No? Who say yes, they are equal? Because y to the power of 4 is y times y times y times y, right? So if I have xy to the power of 4, is it x times x times x times x times y times y times y times y? You think it's xy times xy times xy times xy, huh?
No, it's x.
Is it? Is that what it is? Is it just y? This one equals to y?
X times 4y.
You understand what my question is?
Yes.
Understand now? Okay. So my question is, what exactly does xy to the power of 4 means? Yes, Nicholas. Yes. Okay. belonging to the immediate thing at the bottom. Immediate one at the bottom. Unless there are brackets. Okay? Unless there are brackets. Alright, so brackets serve a different thing. Okay? So this power of 4 is only belonging to y. So only y repeats 4 times. Whereas x is only 1x only. Okay? Because if it's supposed to be like that, then I wouldn't have things such as this already. Right? So please be very clear that this is equal to this. Alright? These two over here that are written in red, they are actually equal to each other. Because xy times xy times xy times xy is still 4 x's, alright? And then 4 y's. Okay? So these two actually is the meaning of xy bracket to the power of 4. So make sure that you are clear about when there are brackets and when there are no brackets. Okay? Because if you're confused with that, then it will affect the way you cancel. Right? Any questions? Okay? Then now let's really get into the solving. So 27 over 12. Okay? What's the common factor? Right? Before you start to crack your brain in terms of trying to determine what's the common factor, just use calculator lah. Alright? Because these are numbers. So 27 over 12, what's the simplest form that you're going to get? Sorry? 9 out of 4. Okay, so we just write 9 over 4 lah. Right? When we cancel like that. Okay? Then at the top, okay, we got x squared. X squared is x times x. Bottom we only got a single x, 1x only. So I can only cancel how many x? 1 time. So I just cancel away the 2 and then 1 at the bottom, so that I'm only left with 1 single x at the top. Alright, only left with 1. Okay? If you want to, you can cancel the whole thing lah, then you write single x on, which is also fine. Alright? Then after that, between y cubed and y to the power of 4, how many y's can we cancel? 3 y's. Okay, because smallest one. Alright? So if you cancel away this one, I will only be left with a single y at the bottom. So actually it's cancel thing y. So what do I have left in my entire fraction? I will have 9x over 4y. Okay, so you must look carefully. Some of you got very bad handwriting. Okay, you cancel all over the place, then you cannot see what is left. Then that's why end up the answer like that lah. Okay, got a plus and a fraction sign only. Okay, so please, handwriting very important. Don't try to cram everything into one writing line. Okay, you can actually afford to have 2 lines so that it's really easier for everyone to see. Okay. Now let's take a look at part B. Okay, for part B, right, we got this fraction. Okay, so just now I said that if there's a plus and minus, we got to be very careful, cannot anyhow cancel. Okay, but if there are brackets involved, the brackets serve as a grouping function. Okay, so they're telling you that x plus y is a group. Okay, a group. Alright, so everything is together. So how we go about cancelling? Okay, 28 over 42. Alright, what does that simplify to? 1. 20 over 42, what does it simplify to? Yes, I hear a number just now. Can press calculator. Okay, what do you get? 20 over 42. So yes. 2 over 3, yes. Okay, so cancel 2 over 3. Alright? Then after x to the power of 4 and x to the power of 7 at the bottom, how many x can we cancel? 4x. Alright? So cancel away. Left with how many x at the bottom? 1. How many? 3, right? Okay. So 7 minus away 4. So that's why left with 3. Okay? So you notice that you have like putting quite a number of things going on, can be very messy. So you really need to help yourself in this. In cancellation, you can cancel whole thing right clearly outside. Also can. Okay. Are there any y's for me to cancel? No, right? Okay. So the y cube over here at the bottom remains there. Right? Then after that, the x plus y to the power of 3 and x plus y squared. Okay, we emphasize that it is a group. So we cancel everything together. Okay, so x plus y to the power of 3 and x plus y to the power of 2. How many x plus y can I cancel? 2 of it. So the one at the bottom totally is gone. The one at the top only left with 1. So therefore my answer will be 2 bracket x plus y over 3x cubed y cubed. Okay, Ryan asked a very good question. Do we need to expand? Not necessary. You can leave it like that, okay? Or you can expand, which is also fine. But make sure you expand correctly lah. If you expand wrongly, then no marks. Alright? So I'd rather you just leave it like that. Because I know some people are very bad at expanding. Later you give me your answer 2x plus y over 3x cubed y cubed. Then you waste your efforts already. Okay? So then this is not the right answer. Alright, any questions? Okay. If no questions, I want to try to cover as much as I can in class. Okay. So the workbook questions they ask you to, the workbook they ask you to read today, perhaps I will actually ask you to do it at home during the home-based learning as part of your offline work lah. Okay. So I try to have more time explaining in class. Right, rather than having time for you to do work. Okay, but of course I know some of you once go home or step out of the classroom, everything forget already. Change teacher, everything that's gone. Okay, so please you can watch the video. I'll upload this video onto YouTube as per usual. Alright, so now, okay, these are the simple ways of actually simplifying a fraction. Okay, there are times whereby it involves factorization. So this type of question was to divide by common factors. Okay, so example 1 was on dividing, okay, or cancelling common factors. Very straightforward. Cancel only. Okay. Example 2, we need to do something. Okay, because if I maybe write example 2 out first, in part A, if I have something like that, then just now we already acknowledged that I cannot take this, cancel here, take this, cancel here. Correct? Because in between got a plus. Alright? So that means I need to do something else. Okay? Which is to do factorization first. Right? So how do I go about doing factorization? Okay, so before that, I will draw some comparison between numerical and algebra. Okay, so first one, if I have 2 plus 6 over 14, I know that 2 plus 6 over 14 plus 6 is 8 lah. So 8 over 14, right? And then we see that there's a common factor of 2. Okay, so if I were to just be very detailed in the working, I'm actually saying this, then I cancel, so my answer 4 over 7. Right? Okay. I can also see this idea of taking out common factor if I have 2 plus 6 over 14, right? Right at the beginning, I write it as 2, I factorize. Can you remember how to factorize? Extract common factor. If I take out a 2 divided by 2 is what? 4. 2 divided by 2 is 4? 1. Okay, 6 divided by 2 is 3. So actually if I do rainbow, right, I will get back 2 plus 6. So 14 is 2 times 7. Right? So then I can also cancel. 4 1 plus 3 over 7, which is also 4 over 7 now. Right? So you see that for numbers, not an issue. We are just using numbers to show you first. Then what about in algebra? If I have AB plus AC, and then after that at the bottom maybe ABC like that, we just now say cannot anyhow cancel, right? So we learned that we must factorize. What I must do is that at the top, okay, AB plus AC, we take out common factor, which is A. What will be left inside the bracket? B plus C, right? So I'm trying to actually help you recall the concepts that we learned over HPL, factorization. So left with B plus C, and then left with ABC at the bottom. Okay? Then now I've got multiplication going on over here. A and B plus C is together. Okay? So now that I have multiplication going on, then I can do my cancellation. Cancel only the A. So the answer will be B plus C over BC. And then that's it. Cannot cancel anymore. Any questions? Yes, Victor. What about the AC? What do you mean? At the top. AC, the A was factorized out, huh? It was taken out, right? So A is here. You remember your factorization? Okay. So if I were to rainbow method it back, okay, I'm going to get AB plus AC. That's why the tops are equal. Understand? Right? Does anyone need me to repeat? Okay, this is my only opportunity that I get to really go into revising the whole process of factorization. Okay, so I'll do it along the way. Right? So, next. What if I have 2 over 6 plus 12? Okay, so we know that 2 over 6 plus 12 is 2 over 18. 2 is 2 times 1. 18 is 2 times 9. So actually, when I cancel, simplified form is 1 over 9. Okay, so I can do it like that for numbers. Or if I do it like something what I do for algebra, right at the start. Okay, I factorize out a 2. Okay, why I choose to factorize a 2? Because I want to cancel the 2. So I get answer 1 over 9. Okay, maybe for numbers, you wouldn't quite understand why I do such a long method. Best calculator can really work. That's true lah. Okay, but why I'm doing such an elaborate step is because when we go into our algebra, if I were to have AB over AC plus ABC, I also cannot anyhow cancel because down here is a plus. So I must do factorization. At the top, nothing for me to do. Bottom, okay, what can I factorize out? A. Between AC and ABC, what is common? We got A that is in common. Anything else? Hello?
C.
C, okay, we got a C that is in common. Then I put brackets. AC, take out AC already. What will be left?
1.
1. Okay, it's not nothing, it's 1. Because in the idea of factorization, we're doing division. So AC, I divide by AC. Same thing, divide by same thing is 1. Right? 2 over 2, 2 divided by 2 is 1. Okay, so I get 1 here. Then after that, we handle the plus ABC. Plus ABC, I have already taken out AC. What will be left?
B.
B. So this is how we factorize the denominator. Do you understand? Some of you are still scratching your head. You really got to ask, you don't quite understand. Okay? So, then after that, we move on. Now that we have AC times 1 plus B, that's a group. Okay? We do our cancellation. So we cancel away A. B, we got nothing to cancel. Because this is 1 plus B. It's together. Right? So C, we also got nothing to cancel. So our final answer will be B over C bracket 1 plus B. Alright? Okay, any questions? Yes, Geraldine. Okay, maybe we do more, then after we can fully understand. Alright? So for question 3, the numerical example, maybe I'll just skip that. Let me just look at AB plus AC over ABC plus AC. Alright? How to actually do the factorization. Okay, AB plus AC factorize, what do we get? Peter, let's try. Very good. A bracket B plus C, so take out A, left with B plus C. Okay, what about in the denominator? ABC plus AC. Actually, what do we get? What can we take out? Sorry, I can't hear you. I can't read your lips. Sorry? Take out AC, yes, very good. Okay, yes, you are right. So AC is in common between both of it, so we take out AC only. But can you tell me now what is going to be left inside the brackets? ABC, take out AC already. What's going to be left? B plus 1, yes. Right? So AC, I've taken out AC, so I'll be left with 1 here. Right? Then now I do the cancellation. I can cancel away the A only. Okay, because this things in bracket is B plus C. The things in this bracket is B plus 1. They are not the same, so cannot cancel. So the answer at the top, B plus C over C bracket B plus 1. Okay, at the top no need to really put brackets anymore because there's nothing to separate out. But even if you put, it doesn't quite affect the meaning. Alright? Any questions? Okay, now let's go into example 2. Okay, so now understand that we need to factorize. And by the way, factorization is not limited to just taking out common factors. We got learn cross method also, if you recall. Okay, which I can see that some of you are rather weak in through your homework. But it's okay. So let's look at part A. We got x cubed plus 8xy cubed. Okay, at the top, need to factorize. How to factorize? Angel, I see that you're not copying anything. I hope that you're listening. So let's test you. X cubed plus 8xy cubed. What is in common? How many x? 1. Very good. And then what's going to be left inside the brackets? X squared 8y 8y what? Cube. Okay, very good. Alright. So there's only a single x that is in common. Okay, so we can only take out 1x. Then we're left x squared plus 8y cubed. Right? Then at the bottom, it's only a simple 16xy, so nothing for us to do. So leave it that way. Alright? Then now we can do our cancellation. We cancel away only the x. So final answer, x squared plus 8y cubed over 16y. Yes, Xavier. Why cannot cancel the 8 and the 16? 8 belongs inside the brackets, alright? Okay, 60 is not in the bracket, so cannot cancel. So it brings back to our example just now, where I mentioned A plus B over AB cannot like that cancel, right? Because this is separated by a plus. Okay, so it is within that grouping, so cannot cancel, right? So it's not limited to your letters, it's also extended to your numbers, right? Good question though. Now let's look at part E. We got 20x over x squared plus xy squared. Okay? How should I deal with this? Howard, anything to work on at the top of the fraction? No? Okay. What about at the bottom? X, 1x, okay, take out 1x, is it? Then, bracket, x, then, plus, sorry, y squared, very good. Okay, so we have this. Then now we simplify. Alright, we cancel away this x only. So answer 20 over x plus y squared. Okay, part C. Yes, Chpt.
May I know why like after we cancel the x, we need to take out the bracket?
Why we cancel the x?
No, why we after we cancel the x,
Uh-huh.
we have to take out the bracket?
Oh, you can leave the brackets here. Okay? Because the idea of the brackets over here is to serve as a multiplication. Okay, multiplication of what? Multiplication between x and x plus y squared together. So now that we have already cancelled away the x, the brackets serve no purpose anymore because it has nothing to multiply with. So that's why I can just reduce my writing by removing the brackets. You can leave the brackets there. There's nothing wrong with it, but it serves no purpose. Okay. Now for part C, x squared minus 3x over 3x minus 9. Declan, you look very bored. Tell me how to do this question. X bracket x minus 3, good. Then at the bottom, leave it as 3x minus 9. But can cancel anything?
The 3.
This 3 and 3 can cancel. Cannot, right? So it's not helpful, right? Is it helpful? Or what are you thinking about? Cancel the x, this x. But can cancel, man? You see the way I cancel? Do I go into the brackets and cancel? I don't, right? Okay, I never cancel inside a bracket. So something is not right. Okay, I cannot cancel inside here on the minus sign. So there's something that we need to do with 3x minus 9. Can we factorize 3x minus 9?
Yes.
Damien, you want to try? Divide the 3 and the 9. So I factorize out a 3. I cannot just divide it away. I need to write out the 3 times x minus 3. Okay? Then, now that we have done this factorization at the bottom, what is it that I can cancel? X minus 3. So I can only cancel x minus 3 in this manner. So therefore, my answer will be x over 3. Okay, so I show you one example on how to cancel. Alright? Any questions? Okay, I'll just end here. delay, I don't drag on. Okay, let me give you some instruction over what to expect for the next lesson. So next lesson, right, I will go back and then do a video for example 2 part D and example 3. Right, I will do a video for example 2 part D and example 3. After you finish watching the video, then I will assign you to do your workbook exercise 7A, question 1, 2 and 3. Okay, I'll let you go and do it. Then after that, after you have done it, okay, you can go and check your answers yourself. Alright, I will give you a soft copy version of the answers as well as the video explanation of the workbook questions. So I will be working on that over the weekend so that you can go and learn it for the next lesson. Then after that, lesson number 2, I will do chapter 7.2. Okay, all these instructions I will place it on Google Classroom. So always just directly go on to Google Classroom to check for the latest announcement, just like before. Alright, any questions? Okay, thank you everyone.